Hello guys, this is Prime Concept. You're welcome once again to my channel. Now, just very importantly, I've been looking at a series on WAEC Practical Physics Preparation, and I promise to help you through this WAEC Physics Preparation 2026 so that when you get to the exam hall, your confidence will be raised from, let's say, 20-something% to about 99%. So in this video, I want to consider a very important aspect of practical physics. Now, a lot of students have been wondering and asking me that what is the nature of the experiment that you are expecting in the 2026 WAEC exam. And I now realize that beyond knowing the nature of the experiment you're going to do in that exam, one of the major things that determines your performance in your WAEC practical physics is your ability to plot a good graph. Now notice I said a good graph. So it means that when you plot graph, how do you know that your graph is even correct? In this video, I'll be showing you powerful points that you have never learned from anywhere. And one of the things I'll be teaching you in this video is that I'll be teaching you how to plot graph in your WAEC exam hall, how to plot graph in less than 5 minutes. You'll be done plotting one graph. Remember, for your WAEC exam, you might be plotting around 2 graphs, a minimum of 2 graphs. You might even be required to plot about 3 graphs, but a minimum of 2 graphs in your WAEC exam. So how do you maximize time such that within a short time, as little as 5 minutes, you'll be able to plot one graph? So I'll be showing you the skill that can help you plot graph very fast. Another thing which is the most important to me and even to you is when you plot your graph, how do you know that the graph you have plotted is correct? Now, some of you might think that you can only know that your graph is correct when they mark your graph. No, there's a secret. The secret that the examiners know. I'm going to give you that secret such that every graph you plot, and that graph is a straight line graph, you can tell the answer of that graph. So trust me, if you're following me on this channel, keep following. If you are yet to subscribe, hit the subscribe button, because I will be making series of videos. By the time you're done watching these videos, when you get to your exam hall, you will do marvelously well and you return back to thank me on this channel. So very quickly, let's get into the business for today, which is the concept of graph plotting for WAEC. Graph plotting. So we'll be looking at how to plot graph, the WAEC standard, and I'll be plotting one graph with you based on a kind of experiment we're expecting. After teaching you graph plotting, my next sessions of videos are going to be on the possible expected experiment. I'll show you how to now get the values. For now, before you need those values, you need to know how to even use them, which is the concept in graph plotting. Now, in WAEC graph plotting, 2 types of graph you can meet are: number 1 is a straight line graph, which is consistent. Number 1 is a straight line graph. So in this 2026 exam, one of them must be a straight line. The other one I'm expecting might be a curve. So it means we'll be learning the 2 types of graph. So you have a straight line graph, and then number 2 is a curved graph. A curved graph. So these are the 2 types of graphs that WAEC would be releasing this year, 2026. Now, when you're given any of these experiments and the graph is a straight line, one of the beautiful things about a straight line graph is that your slope is a constant value. So it means that when they'll be marking your practical physics, WAEC already has an expected answer. How did they even know that expected answer? I will show you how they got to know that expected answer, the end point. I will give you the end point so that when you are done plotting your own graph in the hall, you can beat your chest and say, this one is correct. All right? Yes. Now, number 2 is a curved graph. Now, for a curved graph, the slope is not constant. So it means that you can get different slope for your curved graph. So if you finish plotting and it is a curve, then you should be happy, because once you get your slope, it will be accepted as long as you have chosen the right scale. So these are the two types of graph you're going to meet. Let me quickly lay a little more emphasis on a straight line graph. For straight line, you can have two types of straight line. So one, your straight line can either go this way, that is to say, it is moving from the left to the right. This is one type of straight line you can have. Then another type you can have is this way, that is to say, moving from the, moving, let's say, from the left downwards, upward to the right, all right? And then this way, from the left downwards to the right. So these are the two types of straight line graph you can have. Now, what's the difference between both of them? The difference is you don't even need to know this shape for your answer to become this shape, right? Once your points are arranged, you've gotten your points correctly, and you plot them well from what I'm going to explain, automatically they would align either in this way or this way. So you don't need to know. All you need to just understand is that this type of graph is actually what we call a positive graph. So since it is a positive graph, it means it's going to have a positive slope. The slope for this graph is going to be what? Positive. That's why you call it positive graph. Now, what about this one? This one is what you call a negative graph. Is what you call a negative graph. Now, since it is a negative graph, it means that the slope you expect for this is going to be negative. Now, this is where WAEC could get some of you again. Some persons know that this is positive, and they also know that this is negative, but they don't know how to arrive at their slope to become negative for this. Now, I will show you the concept behind this. Now, say you've plotted your graph and you have it in this form, and you want to find your slope. To find the slope of a straight line, what you actually need is to draw a triangle, right? To draw a triangle. And let me tell you, now say you've plotted this and these are your points on your axis, on your best fit line. So these are your points. So let's say this is what you have. Say you have 5 points, you have plotted this graph. Now you want to find your slope. You're going to draw a triangle. Now when you are drawing a triangle from your best fit line, this line you're seeing is what we call line of best fit. Now I will still explain to you how to draw line of best fit. For now, my interest is how to find slope. Now, if you want to draw your triangle, one of the things you consider is that your triangle should be as big as possible. So don't draw a triangle that is being managed as if you're managing space. WAEC don't tolerate that. And beyond WAEC, when your triangle is very small, it increases the error in your graph. So it means if you want to get more accurate slope, you should make sure that your triangle is as big as what? Possible. Thank you. Now, when you want to draw your triangle, another point you should take notice of is you should not draw your triangle from a data point. All these things you're seeing, these are the data points that you have plotted. Don't draw your triangle from a data point. Now, some of you think when you want to draw your triangle, you must draw it inside. No. If I want to maintain a big triangle, I can draw from this point and draw from this point. Can you see how big this triangle is? Now, notice that I didn't draw this triangle from this point. So some people might draw from here like this. When you do that, it is wrong. It's not accepted in WAEC. You're already subtracting your marks. So your data points must be left clean and clear so that the examiner can tell how many points you have plotted clearly without straining their eyes. So it means you draw your triangle from 3 points on your best fit line and make your triangle to be what? Big. I hope this is very clear to you. Please be noting these subtle points, because these are areas where WAEC is going to begin to subtract marks from some persons. So your graph carries as big as up to 9 marks. So you should be very conscious of that. Now, when you have drawn this, you should notice that you're going to use dotted lines. Dotted, don't use thick lines. So you're going to use dotted lines down to this axis. You're also going to do the same dotted lines here, right? You're going to do the same dotted lines. You're going to do the same here, dotted lines. So this is what you're going to do. Remember, don't use thick line. It has to be dotted line. Now, of course, for this case, this is going to be your y1 and this is going to be your what? Y2. Remember, in WAEC, when you're plotting a quantity, you don't label these points. Leave it like this. I'm just labeling because I want to explain to you, right? So you don't label this point, just leave it. You're going to label just your axis, which I'm still going to point out to you, things you should do before you start plotting graph. I'm going to point them out. Now, in this case, this is your what? X1, and this is your what? X2, right? Now let us assume that you have a value. Let us assign some values. Let's assume that at this point you have the value 2, and at this point, let's say you have the value 4. Let us say at this point you have the value 1. Let's say at this point you have the value 3. So if I ask you to find the slope, of this first graph, what is the slope going to be? Remember, slope has the same formula, whether your graph is positive, whether it is negative, whether it is a curve. The formula for your slope remains the same. And what is the formula for your slope? It is y2 minus y1 over what? X2 minus what? X1. So this is the formula for your slope. Y2 minus y1 over x2 minus x1. Remember, you would usually put the units, but I'm coming to that point yet. Now, you want to get the slope of this. What are you going to do? You're going to use y2, which is what? 4. So you're going to say 4 minus y1, which is what? 2, divided by, what is our x2? Our x2 is 3. So 3 minus our x1 is 1. So what do I have? I have 4 minus 2 is 2 divided by 3 minus 1 is 2, and this is actually 1. So you notice that in this case, your answer is positive, it is 1. And let us see this case. So we want to find slope for this case. How do we draw our triangle? Now, don't make the mistake of drawing your triangle this way. Don't draw your triangle that way. It should be inward. The triangle should be what? Inward, right? So if you want to get the slope for this one, now how do you draw your triangle? Very easily, you draw your triangle inward in this case, right? Yes. What do you do now? You trace like this. You trace this one. You trace this one. You trace this one. So this is what you do. Now let's assume that this place is the same value 2 and this place is 4 because you start from lower value going up. Let's say this place is 1 and this place is 3. That way, right? Yes. Now if you want to get the slope of this graph, what is it going to be? Our slope for this case, our slope is going to be, now watch, this is where you have to be very careful, right? You would notice that this place, if you call this place y1, this place is what? Y2. Now, one of the things you should know about locating points is that y1 would always meet with x1. y2 would always meet with what? X2. So let us check. So this is y2. If you trace it and bring it down, it means that what you have here is supposed to be what? X2. Because this is y2. You trace it, you bring it down, where it meets should be your x2. This is your x2, and this is y1. If you trace it and bring it down, this is supposed to be your what? X1. Are you seeing the difference now between a positive and a negative graph? Yes. In our positive graph, you have x1 first before x2. But on your negative graph, you have what now? X2 before what? X1. Don't forget. This is the catch for your negative graph. Now, what is your slope? Your slope still maintains this formula, which is y2. What is our y2? Our y2 is 4 minus y1. What is our y1? It is what? 2 divided by x2, still x2. What is our x2 in this case now? It is 1. So 1 minus our x1. What is our x? Our x1 is 3. So if you subtract, you have 4 minus 2 is what? 2 divided by 1 minus 3 is minus 2. So what is our slope going to be? Our slope is going to be minus 1. So are you seeing why this graph is a negative graph while this graph is a what? Positive graph? And I believe this concept is clear to you. So you need to understand the difference between a positive graph and what? A negative graph. Now moving on, quickly, I want to tell you, for a curved graph, how do you find the slope for a curved graph? So for a curved graph, how do you find the slope? Now say you have plotted a graph and you got something like this. I hope you know this is no longer a straight line. This is a curve. Because when you have a curve, you're going to join it. Now, the mistake a lot of students also make, which I'm still going to explain, is when they want to join, they try to, if it's a curve, they want to join everything. No, please. If you have a curve, if you have points that form a curve like this, you don't join everything. You join the point that gives you a perfect curve. You join the point that gives you a what? Perfect curve. Say you have something like this. I'm doing a freehand sketch. Say I have something like this. I have something like this. Right? Can you see these points now? Obviously, you can tell that this is not a straight line. You can see how scattered they are. It's not a straight line. So if you try to make it a straight line, you have a lot of scattered points. So I would quickly notice that this can be a curve. But most students, when they want to join this as a curve, they will bring this, bring this, bring this, bring this, bring this. You see that it's not a perfect curve. So when you want to draw a curve, you pick just the point that gives you a perfect curve. That is what WAEC approves of. So you don't have to join everything. There are points that will deviate. So you ignore those points. So you have something like this. Now if you want to draw, it would be best to pick something like this. Remember, I'm doing freehand, but you're going to use broom on that day. And you see this? So you notice that I have 4 points that gives me a better curve. I don't have to include this, so I will ignore this. That is how to draw a curve. Now, what if they now ask you in your WAEC, say, find the slope for a curve? So somebody would say, it is not easy to draw a triangle since this is a curve. Of course, you are correct. Now, if you want to find the slope of a curve, what do you need to do? You need to draw what we call a tangent line. You need to draw what we call what? A tangent line. Please, what is a tangent line? A tangent line is a line that touches a curve at one point. It's a line that touches a curve at how many points? 1 point. So I'm going to pick a point randomly. So let's say I've chosen this point as my random point. I'm going to draw a straight line through that point. So something like this. Something like this. So this line I have drawn to touch this curve at just this point is what you call your tangent line. So what are you going to do? You're going to now draw your triangle on that tangent line. You draw your triangle. So with your triangle, you can trace this. This becomes your y2. You can trace this. This becomes your y1. You can trace this. This becomes your x2. You can trace this. This becomes your what? X1. Remember, this curve is going to give you a negative slope. You can see it. The tangent goes this way. So it means it's going to be negative. So this is how you can find slope under your WAEC condition. Now, I want to quickly explain to you what are the things you need to consider when you are plotting graph based on WAEC, so you don't lose unnecessary marks. I'm going to give you those points now. So while you're watching me, remember that we have a lot of things to unravel. Your WAEC exam practical physics, I believe, is very close, and you know it. You have less than 3 days to your practical physics. So I need you to subscribe to this channel, because I'll be pushing a lot of videos that will be helpful to you in that practical. Don't forget, your practical physics takes 50 marks. 50 marks, and I know you don't want to be careless with 50 marks. So this 50 marks is something I usually tell my students that they can easily get. Out of 50, if you are too careless as my student, you can get up to 45 over 50 if you are too careless. So what you want to do is to subscribe to this channel. So when I upload any of this WAEC practical physics question, you'll be among the first to be notified. Remember, we're still here for NECO. We're still here for JAM. We're still here for University 100 level exams. So we are versatile and you need to be following us, all right? Thank you. Now, what are the things you need to know and understand when you are plotting WAEC graph. Number one thing I need you to know and keep at the back of your mind is you need to write the title of your graph. You need to do what? Write the title of your graph. You need to write the what? Title of your graph. It's very important. So it means when you have your graph sheet, the first thing you're going to write is the title. You write the title above. This is the format for writing your title. You can write the title. And let's say you are plotting a graph of voltage against current. So you're going to say a graph of V. What's the unit of the V of voltage? It is volts. So a graph of V against current I in what? Ampere. So this is how you write your title. You include your unit. Don't forget to write the unit. They are looking for you to get you at this point. So you must be conscious. In physics, we don't joke with units. So don't forget to put the unit. This is how you write your title. Let me show you a graph. So say you have this. Say you have this graph. You have this. So you can see this clear space. This clear space, use it for your title so that it will be obvious to the examiner. Alright? Yes. Because when you write inside this box, you will not be penalized, but it is best to write on this white space so that it will be very clear. Your title will be obvious. Alright? Now, so this is the first thing you write, your title of that graph. And the next thing I need you to write is your scale. You write your what? Scale. Now, this is like where a lot of students have challenge, and I'm going to clear that challenge in this video. After now, you would never be unable to choose scale for any graph. I'm going to give you what I call the 3 magic numbers. Trust me, with these magic numbers, you can never fall into the trap of choosing scale again. Now, so you need to write scale. Now, how do you write your scale? How do you write it? Not how to choose it. How do you write it? So after your title, what comes next is your scale. Please, you're doing physics and not mathematics. Don't write something like this for us, 2 cm ratio 0.5 units. If you do this in this physics, you have lost this marks. You only do this kind of thing in mathematics. You don't do it in physics. So in physics, you tell us what you are doing in words. So when you want to write your scale, what you're going to do, remember you're plotting voltage. When they say V against I, it means that you're plotting V on which axis? On your vertical axis. You're plotting I on which axis? Your horizontal. That is what this statement, V against I. V on the vertical, I on the what? Horizontal. Are you following me? Yes. Now, how do I write the scale? I would say, remember WAEC standard is always a 2 cm graph. In WAEC, you're using a 2 cm graph. 2 cm graph, that is WAEC standard. So now, this is not the WAEC standard graph, but you can still be used. Now, in this case, one of these box, this big box you're seeing in this particular graph is actually 1 cm, this big box. But 2 cm is 2 of these big boxes. So from here to here is a 2 cm, right? So WAEC usually combines these two as one box. So WAEC is 2 cm standard. So it means I want to write my scale. I will just say 2 cm represents, let's say, 0.5 units on the V axis. Now you don't say Y axis. You talk about the quantity you are plotting. You say V axis. I don't have to put the unit again, right? Yes. Then for the horizontal, you also say, because it's always 2 cm. So you say 2 cm represents, let's say, 0.2 units on the I axis. So I axis, you don't say X axis. So you say what? I axis. So this is how you write your scale. Are you following me? Yes. Now, that is the next thing. Remember, you've written your title, your scale. Then, number 3 thing I want you to take note of when you are plotting your graph, I need you to be marking your data points using a plus sign. Using a plus sign. Don't use a big dot to be marking your point. You saw what I illustrated. So it's best to use your plus. When you use this and you want to draw your line of fit, you see that it will go through the center of that plus. Once it goes through the center, you can tell that this point was accommodated. But when you use this big dot like this and you are drawing like this, you can see that you don't even know where this line is passing, whether it is touching that point or not. But this one, once it goes through the center, you can clearly state that it touches this point, right? Or if you have something like this and then it goes this way, you can see that it didn't go through this point because it didn't go through the center. So you can clearly state which point was accommodated and which one was not accommodated. So I said you use a what? Plus sign when plotting. All right. Now, another thing you should take note of, which I've already mentioned casually, is that number 4, let me say number 4. Number 4, label your axis. Label your axis. Now, how do you label your axis? Remember, you have 2 axes. You have your vertical axis and you have your what? Horizontal axis. Now, when we say label your axis, you label your axis based on the quantities being plotted. You label your axis based on what you're plotting. So if we consider what we just plotted, it means if I want to label my axis like this, I am going to call this place, I'm not calling this y-axis, that is for mathematics. In WAEC physics, you label here as what? V-axis, and you must include the unit. So V-axis in what? Volts. You label this place as what? I-axis in what? Ampere. So this is how you label in physics, based on what you want to plot, not x and y. No, it's not accepted, right? You label your axis. Very important. Then I already casually mentioned this point I want to say now. When you're drawing your triangle, make sure you don't draw your triangle through a data point. I'll still explain that when we now plot a real graph. Now, somebody may ask, sir, prime concept, when you are finished plotting your data points, how do you draw your line of best fit? That is the easiest thing you want to learn today. All right, how do you draw your line of best fit? Now watch. First, what is line of best fit? Line of best fit is a line that goes through as much data points as possible. It is a line that does what? That goes through as much data points as what? Possible. Leaving the unaccommodated points evenly distributed. Now, what do we mean by this statement? Watch me. Now, let us say you have plotted your graph and you got things like this. Let's say you had this kind of point. I'm just doing a freehand sketch. Hopefully it will illustrate what I want to give you. Let's say you have plotted and this is what you got. And you want to draw your line of best fit. So you're going to draw your line of best fit through this. Remember, these things are what we call data points. How did we even arrive at this? That is the next thing I will teach you. How to locate your data points. Too important to ignore. So don't watch this video halfway, because at the tail end of this video, I'll be revealing powerful concepts that will now give you that 99 boost in your confidence against your practical, such that you would finish your practical graph and you'll be looking for more graphs to plot, and they will tell you, Mr. Man, you are done, submit. So follow me. Now, you want to draw your line of best fit. I said your line of best fit is a line that will touch as much of this point as it can touch. And if there are points it will not touch, make sure those points are evenly distributed. Now, see what I mean? I'm going to join. Remember, this is a freehand joining. This is a freehand joining. Now, observe what I've gotten. So now, see what I've done. Now you notice that my best fit line touched how many points? It touched 1, 2, and 3. It only touched 3 points. And how many were not accommodated? You are correct. 3 points. You have 1, 2, and 3. So this is a line of best fit and it is perfect. Why is it a perfect line of best fit? Because my 3 unaccommodated points were evenly distributed. You notice I have 2 of them below, at the lower side of this line of best fit. I have 2 of them. At the upper side, I have 1. But if I had joined this in a way that these 3 unaccommodated points are on the same side, say you have the 3 of them on this side, 3 points were not accommodated, and the 3 of them are on one side, it means that this is no longer qualified to be called line of best fit. So for it to be line of best fit, you must draw it in a way that if 3 points are not accommodated, make sure 1 of them is up, 2 are down, or 2 of them are up, 1 is down. There must be an even distribution. Remember, if you have 2 points that are not accommodated, how will you distribute them? 1 and 1. Right? Because it is equal, 1 and 1. If you have 3, it should be 2 and 1 or 2 and 1. If you have 4 points that are not accommodated, it should be what? 2 and 2. That is what we call even distribution when you're drawing your line of best fit. This is too important for WAEC. Don't joke with it. So this is how you draw your line of best fit. And I believe that the concept is very clear to you. Now, if you have drawn your line of best fit, of course, what is left for you is to draw your triangle. Right? And I've told you that when you're drawing your triangle, don't bring it from a data point. Don't draw it from a point. Some people will draw this way. Don't do something like this. This is too wrong in WAEC, and you'll be losing unnecessary marks. So draw it from a free end and make sure that this triangle is as big as what? Possible. So this is what you need to know. These are some of the important points that you need to take note of when you are trying to plot graph. Now watch. If you have drawn your triangle for your graph, I've mentioned this already. You use dotted line. Yeah? You use dotted line, you use dotted line, you use dotted line. Please don't label. Don't come and label here, say Y2. Say don't label, just leave them free like that. Don't cluster your graph too much. It has to be neatly, it has to appear neatly. So don't come and label, just leave it. Leave it. We know that this is Y1. And we also know that this is Y2. Alright? Don't give us those information. It's not useful. Allow your graph to be neat. Some people are used to coming inside their graph and they will now say slope. You now start doing your calculation of slope inside your graph. Please don't do that. It's not accepted. And also make sure that when you're plotting graph, you maximize the space. So use at least 50% of your graph space to plot your graph. So maximize the space you have. So don't make your calculations inside your graph. It's not accepted. All right, so you have a space provided for your calculations. So these are basic secrets that some of your teachers would not tell you, and I'm revealing them. Remember, at the end of this physics practical class, I'm going to be showing you what I call the wonders of practical physics. And what is that wonder of practical physics? It is when you finish plotting your graph without WAEC marking your graph. How do you know that your answer is correct? I'll show you that secret at the end of my videos for practical physics. That is the end point revelation. If you know someone that has not subscribed to this channel, don't forget to share this video with them. Always like this video. Always like our videos. Drop comments telling us what next you want to learn, and I'll be revealing those things to you. All right, remember, we're going to be making videos on the possible experiments, and we're going to be doing it together. In those possible experiments, I won't go with the convention. I'm going to teach you a new idea. In those experiments, I will show you how to generate your table of values for this possible experiment without you performing the experiment on that day. Because of what? time constraint. So I have a lot that you can't afford to miss. Just do well to subscribe. And the next thing I want to teach you in this video is how do you choose scale. Because if you want to plot graph, the most important thing you need to do when you want to plot graph is to have the right scale. If your scale is wrong, or if you don't get a good scale, it means that you're going to miss a lot of things in that graph, and you eventually miss your slope, which is the end point. So how do you choose scale? So I'm going to show you how to choose scale. How to choose what? Scale. And after which we're going to now plot graph. So maybe in another video, now I'm going to show you how to plot graph. Alright? How to choose what? Scale. Alright? Now, if you want to choose scale, first I want to tell you that there are certain values that are accepted in WAEC. Now, you don't choose scale using something like 0.3 as your scale, or you say what is the name, or you say 6, your scale is 6 units. No, there are certain accepted values of scale in WAEC, and those values must be simple. So I call it the 3 magic numbers of scale. 3 magic numbers of scale. What are those magic numbers? It is 1. So your scale can be 1 unit. Your scale can be 2 units. Your scale can be what? 5 units. So these are the 3 magic numbers in your scale. Now, your scale can be a derivative of these numbers. So anything that is derived from this is accepted to be your scale. Anything outside this is not accepted as your scale. What do I mean? I can use a scale of 0.1, it is derived from 1. I can use a scale of 0.2, is derived from 2. I can use a scale of 0.5, is accepted, right? Yes, I can even use a scale of 0.01, still derived from 1. I can use 0.02, I can use 0.05, and so on. I can even use, if I add 0 to all this, I can use 10, I can use 20, I can use 50. If I keep increasing, I can even use 100. If I add 0 to this, I can use 200, I can use 500. So that's why I call this the what? The magic numbers of what? Scale. So if somebody comes and decides to use a scale of 0.4, please, it is not accepted in WAEC, because it is difficult to calculate when you're plotting your graph. So WAEC prefers simple values. Some of you may be asking, what do you even mean by this? What I'm saying is that if you tell us that your scale is 2 cm, represents 0.4 units, this will not be accepted, because it does not fall within this kind of values that can be used as our scale. So rather than using 0.4, the nearest match to 0.4 is what? 0.5. So 0.5 is accepted scale, right? Now, so since you have known the possible values that can be used as your scale, how do you find it? I have developed a formula that can help you under exam condition, so that you don't strain your brain, you don't stress yourself. You just punch your calculator, and then you do what? You get your scale. So for vertical axis, you want to get your scale. Remember, you need to get scale for your vertical axis, and you need to get scale for your what? Horizontal axis. So for your vertical axis, how do you get the scale? It's going to be range over 8 for your vertical axis, and for your horizontal scale is going to be what? Range over what? 6. So these are the 2 formulas you need to be able to get scale under exam condition. Now, when you use these formulas to get an answer, some of the times you get decimals, or rough decimals. Now, when you get an answer, you ask yourself, that answer is closest to which of these possible kind of scale? I'm going to give you an illustration. But one of the things you should have at the back of your mind is that when you are picking that answer, you always pick upwards. You approximate upwards. Don't approximate down. Don't approximate backwards. Always take it high, and I'll explain what I mean, and go higher than what you have. Now, this is what I mean. Let's say we have this set of values and want to choose our scale. Say we have this set of values and we're going to be plotting the graph. Now, but let's say we have this set of values. We have V in volts, we have I in ampere, and these are the values for this. We have 0.9, 1.7, 2.1, 2.3, 2.4, and here we have 2.06, 1.27, 0.91, 0.72, and 0.59. So these are the values we have, and we want to plot. Now. Say we are plotting a graph. I'm sure you have taken note of this formula. And say we are plotting a graph of V against I. So which simply means we are plotting V on which axis? The vertical axis. You are correct. We're plotting I on which axis? The horizontal axis. You are correct again. Now, if I want to get the scale for my vertical axis, so my vertical scale, I'm going to do range over what? 8. Now, for my vertical scale, remember this is what I'm plotting on the vertical. Range simply means highest minus lowest. So what is the highest value here? It is what? 2.4. So I have 2.4 minus the lowest, which is what? 0.9 divided by 8. So if I do this to give me a rough value, then I'll compare it to my magic number. So 2.4 minus 0.9 divided by 8. So this would give me 0.1875. This is the kind of rough value it gives me. Now, if you look at your numbers, I told you your scale can be 0.1, can be 0.2, it can be 0.5, but this is where you're going to pick from because you already have 0 point. So it means you should pick your scale from this. And I told you that when you are approximating forward. It is not the normal approximation you do in math. You just take it forward to the next magic number. Now watch. 0.1875 is actually 0.2. So it means this is just around. So I'm taking it forward. It means I'm going to use which one is forward? 0.5. So it means when I want to plot the graph for V, my scale is going to be what now? 2 cm represents 0.5 units on the V axis. On the V what? Axis. I got this by calculation and I took it forward. I approximated forward, not normal mathematical approximation. This just gives you an idea. Take it to the next magic number, which is 0.5. So it means I'm using a scale of what now? 0.5 to plot my graph. Did you see that I didn't need to stress myself looking at these numbers, trying to get something? No. I just used a formula, got my scale, compared it to my magic numbers, and chose my scale immediately. What about the horizontal? I want you to pause this video and try to get the scale for the horizontal axis. Then comment your answer, then play it and check if what you got is actually correct. Now, I want to get the scale for the horizontal axis. I want to get the scale for the horizontal axis. I'm going to also do range divided by 6, right? Range divided by 6. So for the horizontal, what is the highest? It is 2.06 minus, what is the lowest? 0.59 divided by what? 6. So when I punch this again, I would have 2.06 minus 0.59 divided by 6. This would give me 0.245. This is what this would give me. Yes, I hope I punched it. Now this is what this would give me. 0. So if I compare this to my magic numbers, taking your answer forward, this is what you got, which is already bigger than this. Going forward is going to be what again? 0.5. So it means I'm going to say 2 cm represents represents 0.5 unit on the 0.5, sorry, on the I-axis. So I've gotten my scale again. So is this concept not wonderful? If you really find this valuable, please drop a comment. Tell me that wow, that you enjoyed using this formula to find your scale. Now, since you've learned how to get scale, the next thing is how to plot graph. All right, I wouldn't want this video to be too long. So what I'm going to do, I'm going to post the next video, and that's why I said you should subscribe to this channel. My next video is going to be a video on graph plotting. Now, plotting the actual graph using everything you have learned in this video. How do we now plot a kind of graph that we are going to meet in the WAEC exam in our practical physics? So what we are going to do now, in that graph plotting, remember, graph plotting simply means you're going to have to plot V on this place and then I on this place. How to locate those points, how to find this, how to get all these things. I'm going to show you the fastest and the shortest ever known secret for locating this point without stressing yourself, because some students used to find it difficult. They say locate 0.72 because it is a decimal number. They don't know where to locate it. I'm going to give you a secret. So what I want you to type in the comment section is type "give me the secret." Once you type it, you see the next video where I'll be illustrating by plotting a graph, and you'll be following me to plot that graph. And then after which I will show you that secret. What is the secret? When you finish plotting and your answer is correct, how do you know? So stick with me in this channel. You are yet to subscribe, hit the subscribe button, like this video so that YouTube will recommend it to a lot of your friends and colleagues that are writing and preparing for WAEC. So hit the like button, drop a comment, don't forget to share with your friends. Tell them Prime Concept is revealing the concept behind practical physics. I'll see you in my next video. Thank you.